Hello everyone, welcome to this course in which we will cover all the major React hooks. This course is beginner friendly because we will cover each hook in details. We will start by taking a look at the rules of hooks, and then we will dive into each of the hooks in details, starting with defining state, working with side effects, optimizing React application, accessing DOM elements directory, managing global state, and so much more. So welcome and enjoy. The useState hook is the most important hook in React because it is used to define the state. You can think of state as a built-in feature in React that allows us to manage data that changes over time. This is important because we are easily able to create dynamic UIs in React, as we will see with the examples in this particular video. Now, there are two main rules of hooks which I would like you to consider while working with hooks. And the first one is that you should only call hooks at the top level of your component. So you should not call hooks inside loops, conditions, or even nested functions. This ensures that hooks are always called in the same order and that React can maintain proper state of each hook. The second rule is that you should only call hooks from React functional components or from custom hooks. So you cannot call hooks from class components or from regular JavaScript functions. So now right here we have a simple React application, and all we have at this return statement is a React logo, as you can see on this other side. And then we have a button that we will use to show or hide this React logo. And then right here we have another button that we will use to implement a counter functionality. So let's get started with showing or hiding this React logo by making use of the useState hook. First thing that we need to do is to import useState in this particular component, and we can just say import. Then we use these curly brackets to destructure useState from React, like that. Now, to call this useState hook, we need to do it at the top level of our component before creating other functions or even returning anything. Right here, just after our function declaration there, we can now call useState and we invoke it. Once we call it like this, it usually returns an array, and we can store that array in a variable. So right here I can say const array is equals to useState, and then right here we can see what we have in this array by logging it to the console. So I'll say console.log of array, and I'll go ahead and save that file now, and I can hit refresh here, and I'll open the console by hitting F12. And you'll see here now we have an array being logged at the console, and once we check this array, it has two things. It has the first thing here as undefined, so this is a value of undefined, and the second thing is a function. So usually the useState hook will return a value and a function, and this function we can use it to update this particular value. Now this is undefined because we don't have any default value set for our useState, and we can set a default value right here. So the value that can be passed right here can be of any data type. In this case, we will pass false, which is Boolean, but it can also be a string. It can be an object, it can be a number, it can be an array. So basically you can pass any data type right here. And in this case, we pass false. And if I happen to save again, you'll see that this value has updated right here to false. So normally you'll not see developers setting this particular variable right here to be an array like this. We usually destructure these variables into their separate variables, and this is how we can do it. So to destructure an array, just use these square brackets, and we give these two their own names or variable names. In this case, I'll use show and set show. So remember, you can use any word, but it is common for people to use set here and then the name of our first variable right here, okay, so that you know what you are updating whenever you want to update. So now we have these two values show and set show. Show is our default value here, and set show is a function that we will use to update our value. Now we can conditionally display this logo right here using the show. So I can use the curly brackets and I can say show, then end. So this means that if show exists or if it's true, that is when we will show this link. And remember, this link is having our React logo. Now in this case, when I save, you'll see that it disappears because show is set to false. So if I come back right here, we set show to true and save, you'll see that our logo shows. We just need a dynamic way of showing or hiding the logo when we click this particular button. So if we come to this button, you'll see that we have on-click event here, and we are passing a reference function called handle show. So we will include our logic in here to update our state. So to update the state, we can just call set show, and then we invoke it and we toggle the value of show. So I can use an exclamation mark and say show. So we toggle the value of show. And now if I happen to save, come here and click on this button, we can hide the logo. And when I click again, we can show the logo. So we can show or hide the logo by clicking this particular button. So basically, that is how we can call our useState hook and have these two things. The first one being the value, the second one being a function that updates the first value, which is really awesome. Okay, now let's implement account functionality. So the good thing is that we can call this hook as many times as we want. So right here, we can just say const, and for the count, the value, we give it a variable name of count, and we give the function a variable name of set count. Okay, and then right here we call our useState hook, and we give this count a default value. In this case, I'll say 1. So I'll come to this button and I'll dynamically include our count here. Now if I save, you'll see that this has updated to 1 because now this value is coming from our state. But when we click, the count doesn't increase or even decrease. So we need to make use of our set count to update that particular value. And right here, I can just come to this handle count, which is being called by our onClick event here. So onClick handle count, and here we'll say set count. So we pass our count value and we add 1 if we want to increase, and I save. And once I click here, you see it increases the value. Now there is another better way of handling the state or updating the state, but for now let me first show you the problem. So if I happen to duplicate this one and save, so we expect this to update the state twice. So when we click this button, it will call this handle count, it updates the first time and then the second time. But when I do so, it doesn't work as expected. So right now we have 12. When we increase twice, it should be 14, but when I click now, it goes to 13. So one of them doesn't really work because by the time it's being called, it doesn't know that the state was previously updated. So to fix this, we can usually pass a function inside set count that receives the previous state, just like this. So we can say set count, and then we invoke it. Then we pass a function. This function will receive the previous state. Okay, so here the previous state, we can call it previous count, and then right here we can use this now previous count to update the value. So we can say previous count plus 1, but when we double it, we expect it to update the value twice. Okay, right now it's 24, so when I click, it should go to 26. So I click and it goes to 26, so it works as expected. So this is the best way of handling the state, and you can do it also for this one right here. So here we can say set show, we invoke it. Here we'll have our previous show, and we return here toggle the previous show. just like that. And I save. Okay, I can remove this now, and I save. And when I click on this one, it should show and hide normally. But now we are sure that the state will always update correctly. Okay. Okay, awesome. So one last thing that I'll show you is how you can update the state when you have the state as an object. So here, let's have const app state. Then here we'll say set our app state. We can call useState, and we pass our default value as an object. And we can pass both show and count to be our app state. So separating the state like this, it's usually good, but sometimes you might have an object, for example, a user who has a name, email, address, and all those properties, and they need to be in an object. So it's good to know how to update values when they are in an object. We'll have show, and the default value for show can be true, then comma, here we will have now count, and the default value can be 0 or 1. Let's set it to 1. Then we need to change everything else to make use of this app state. So here we need to make use of app state dot show. Okay, we access the value of show, then we show or hide it. Then for this we need to access here app state dot count to show the actual count. Okay, so here let's first comment out everything else. I don't want to remove so that you can reference it. Okay, so let's start with hiding or showing right here. So here we just need to call our set app state function. So set app state, we invoke it, and as I told you, we'll have the previous state. I can just say prev for previous state, and here we will be able to return something. We can also have these curly brackets, and we can usually return the state. So during the return, you might think that we will update our state like this. Since we want to update the show, you might think that we'll return an object that has show there, and then negate the value of show, which will be available at our previous dot show. But this will mess things up. Okay, for sure it will work, but it will mess the other state that is related to our app state. So let me show you. So if I save here and then I click on show stroke hide React logo, look, this hides. When I click again, it shows. So this works, but you can see our count here. We don't even see the default value, because once we click our show stroke hide React logo, that value is totally removed, because it is set directly to this object, okay, which doesn't have count. So the proper way of updating this will be to spread our previous state, and then we update a certain property. So we spread by including the 3 dots right here. So this way we spread previous, then we set our show to be the updated value. So now when I save here and I come here and refresh, you'll see when I click on show, it hides. When I click, it shows, and our count is still intact. And this is the same way that we will do when updating our count. So here at our count, I can paste this one. So here we will spread the previous state, and then here, instead of updating show, we will update our count, and we'll set count to be previous dot count. Then we increment that by 1, and I save. Now when I come right here and click on count, you'll see it increments. When I click on show, I can show stroke hide. So this is how you use objects. You need to spread the state and then update the particular property that you want to update. And that is all you need to know about the useState hook. The useEffect hook is the most important hook in React when it comes to side effects. So you can think of side effects as some form of logic that runs outside the scope of React. Good examples are fetching data from an API, setting time intervals, subscribing to external events, or interacting with the DOM elements directory. So let's dive right in and we'll see some of these examples in this video. So right here, I have this particular application and we will be fetching Rick and Morty characters depending on the ID of the character. So here I have a button that increments the ID by 1. And how do we make use of the useEffect to fetch the data? The first thing that we need to do is to import useEffect. So right here, we will say useEffect and we import it in a similar way that we import the useState hook. And by the way, if you don't know about the useState hook, we covered it in the last video. So I'll leave a link at the description section below to it so that you can go watch everything that you need to know about useState hook and then you can come back to this video. So the first thing, we import useEffect normally from React like we did with useState. And then we use this useEffect at the top level. So we call it at the top level. Now, when we do like this, useEffect usually accepts two parameters. The first parameter is a function. So right here, I'll pass an arrow function like that. And then the second parameter is usually an array. And here we call this array a dependency array. Because basically the useEffect depends on those dependencies to run again. Okay, so how does useEffect run? It will run for the very first time when our component mounts or when our page renders. Okay, so you can be assured that useEffect will always run at least once whenever you call it like this with an empty array of dependencies. But when we include some dependencies, useEffect usually run again whenever those dependencies changes, as we will see in this particular example when fetching the Rick and Morty characters by ID. So let's start right here by performing a fetch request. So I'll just paste some form of code right here, which I already had, and you'll see this code is trying to fetch from Rick and Morty API, and it's fetching a character by character ID. And this character ID right here by default is 1. So we'll be fetching a character with an ID of 1. And then right here we get a response. We convert that response which we get here and we log it to the console. Basically, that is a character now in form of an object. So when I go ahead and save this file, and then we can refresh the page, you'll see that when our component first renders or when our page first loads, you'll see that we are able to get the first character by ID because this useEffect has run. But whenever we change the ID to 2, you'll see nothing happens to our useEffect. It doesn't run again. So useEffect will run again whenever we have a list of dependencies here and these dependencies happens to change. So here we can pass the character ID and now this becomes our dependency. So useEffect will run again whenever this character ID changes. I'll go ahead and save that file and let's refresh again. So first time we get the first character. When ID changes, we are able to get the second character. I click again, the ID changes and we get the third character and so on. Okay, so this is the simplest way and also most common way of making use of the useEffect hook. You have some logic and then you add some dependencies that will make the useEffect to run again whenever those dependencies changes. Okay, now there is one last thing about the useEffect hook, and that is the cleanup function. So we usually add a cleanup function inside these curly brackets at the very end. We usually say return and then we return a function and we call this function a cleanup function. For now, let's just say console.log of cleanup and I'll happen to save. So how does the code run when we have this particular cleanup function? Whenever our dependencies changes and useEffect detects a change, what it will do before running this code, it will first perform a cleanup. So it will perform a cleanup, it will run this function to perform a cleanup, and then after that, it will run this code afresh. So if I click here to change the ID, you see it first perform a cleanup and then it runs our code again. When I click again, it perform a cleanup and then it fetches the third character. And these will go on and on and on, and this prevents memory leaks or even unexpected behavior. But what are the use cases which we might need to make use of a cleanup function? Because normally when fetching data, we don't need a cleanup function. So let me show you some examples of situations which we need a cleanup function. So here I have some examples of when you might need to add a cleanup function, and mostly we add this cleanup to avoid unexpected behaviors or even memory leaks. Okay, so the first situation is when we have some kind of an event listener. So for example, here we are adding a resize event listener and performing some logic here when we resize the window, and we need to remove that event listener before we run this code again. Okay, so this is one of the situation where you might need to add a cleanup function. The other situation is when you have some kind of a timer or interval. So this code runs periodically and you need to clear the timer before you set another timer, okay, so that to avoid having multiple timers at the same time. And then we have another situation here when you are subscribed to external services or APIs. So you first unsubscribe before you subscribe again. So that is another situation. And then right here I have a real world example of a cleanup function, and let's see what we have here. This is from one of my courses here on YouTube, which is a man chat application, and here we were using Socket.io to listen to messages, incoming messages and also incoming notification. So this first code here is listening to an incoming message, and then we are updating the message like that. And then this one here is listening to an incoming notification and it's updating the notification accordingly. Now these are some kind of events, okay? So these are some kind of events that we are listening to, and we need to clear the events before we listen to them again. So right here we are passing a cleanup function, or rather we are returning a cleanup function, and we are switching off the socket for get messages, and also we are switching off the socket for get notification before we run this code again, so that to avoid some kind of memory leaks or even unexpected behavior. So these are some of the situations in which you might need to use a cleanup function for smooth functionality. And that is useEffect. That is all you need to know about our useEffect. Okay, if you enjoyed the video, please make sure to subscribe, and I'll see you in the next one. The useCallback hook is the most important hook when it comes to optimizing functions in React. And in this video, I'll teach you everything that you need to know about the useCallback hook so that you can start using it in your React projects to optimize functions. So right here, I have a simple application which will help us to understand making use of the useCallback hook. And I have several things going on. The first one is this button here, which when we click, it will show or hide this particular title. So when I click, it hides. When I click, it shows. And basically, we will use this functionality right here to trigger our app to re-render. And then right here, I have another button which increases an ID of a character. So in this case, the character is a Rick and Morty character. We will be fetching those characters from this particular API here, and we will be fetching the character by ID. So this button increments the ID count, and then once it increments, we perform a refetch of the new character using the updated ID. So when I click, we get these two, and we get now character with the ID of 2, who is Morty, and when I click, we get 3, and so on. And this particular functionality of fetching the character by ID, we had done it in our previous video when we were taking a look at the useEffect hook. So if you haven't watched that video, I'll leave a link to it at the description section below, and you can learn all you need to know about the useEffect hook. So now let's check the code. you'll see that here we have account btn component, and what we are doing, we are passing a reference to this particular function here, handle character ID, and this function is incrementing the ID by 1. Okay, so we pass it like this, and this is our count btn component. We are logging this to the console to know when this particular component renders again, and we have our button here, we have the onClick event, and we are passing that particular function for increasing the ID right here. So whenever we click this button, it will basically call this particular function and it will increment the ID. Now, another interesting thing that is happening in our count btn is that we are wrapping it with this memo. And this memo is what we call a high order component. And once we wrap it like this, it prevents this count btn to re-render each time if our props does not change. Okay, so this count btn should now only render again whenever our props change. If they don't change, it should not re-render. So that is all about this particular count btn. We have another component right here called character, but we'll take a look at it later on. Okay, so let's just first comment out that one, and let me clear the console, and now I'll show you the problem that we are having. Right now, although we have wrapped this count btn with this memo, it will still re-render. So let me show you. If I click on show stroke hide, you'll see this count btn is rendered right here. If I click again, you'll see it's rendered again and again and again, even though we have wrapped it with memo to prevent the re-render. What is happening is that this handle character ID, which is a function, is changing this right here. So whenever we click show stroke hide right here, our app re-renders because the state change, and if the app re-renders, this function is created again each time. When our memo here detects that this function has changed, it also re-renders our component right here. We want to optimize this particular function so that it does not change whenever we click this particular button, because this functionality here is not related at all with our ID. To optimize this particular function, this is where we make use of the useCallback hook. So the first thing that you need to do is to just import it normally here. So you import useCallback from React, and then we will wrap this particular function with the useCallback hook. You make use of the useCallback, you invoke it, so I call it right there, and I wrap the entire of this function with that useCallback. This useCallback hook accepts two things. The first thing is a function, and as you can see, we are passing a function already. And then the second thing is an array of dependencies. This tells when useCallback should call this function again. Okay, and here what we are depending on is only this particular set character ID function, which is coming from our useState. So we can pass that right here, set character ID. Okay, and by this, what useCallback will do, whenever our app re-renders the first time, it will create this function. But whenever it re-renders again and set character ID is not being affected, this useCallback will not call that function again, or that function will not be created again. Okay, so here, if I happen to refresh the first time, you see everything renders, even our count btn. But now, since we have wrapped this particular function right here with our useCallback, it will not be created on each re-render. So if I click on show stroke hide, you see count btn is no longer being rendered because handle character ID does not change, and this handle character ID is our function. So now that particular component here is properly optimized by making use of both the memo and the useCallback hook to optimize our handle character ID function. And if we check at our increase character ID here, you'll notice that it still increments our ID. So it works well, and it is not being affected by our show stroke hide title here. If I come down here and bring back this particular component, and I'll happen to save, right now, whenever I click show stroke hide title, you'll see we are fetching the character, and whenever I click again, you'll notice that this is fetching the character again, and that is this useEffect being called multiple times because it's calling this particular console log each time. And why does it do so? That is because our handoff fetch character function, which is available at our app, this function, when our component re-renders, it is created again each time. And if it is created again, we are passing it to our character component as handoff fetch, we receive it, and useEffect detects a change in this particular function, and therefore it runs the code that is in here. Okay, so whenever we click, the app re-renders, useEffect detects a change in this particular function, and it calls this particular code again. Therefore it will log this to console and it will fetch the data again. So to optimize this useEffect, we need to make use of the useCallback hook at our handoff fetch character function. So right here, we just need to wrap this particular function with the useCallback. So I'll just say useCallback, and then I call like that, and I cross it like that. And then we also need to pass a dependency array like that. So now when I save and let me refresh, I click on show stroke hide, you'll notice that our fetch character here is no longer being logged to the console anymore because our useEffect is not being called again because this handoff fetch character is not changing on each re-render. So we have basically optimized now our useEffect right here. But now a weird thing is happening because whenever we change the ID to 2, the ID changes to 2, but you'll notice that the character did not change, meaning that the fetch did not happen. So why did fetch not happen in this case? And basically it's because we are not passing our character ID as a dependency right here to trigger a refetch of our character whenever the ID changes. So here I'll copy this ID and I'll pass it as a dependency like that. And what this ID will do, whenever we change the ID here, useCallback will detect that change. It will notice that the ID that is current is different from the previous one. Therefore, it will trigger a call to this function that we passed right here. So let me save. And now, whenever I click on increase ID, we increase the ID and we perform a refetch. And whenever we click on show stroke hide, you'll notice that we are no longer calling this fetch character multiple times, and we are no longer rendering our button multiple times, which is really cool. When do you need to use the useCallback hook? One is when you make use of a memo like this and you don't want that particular function to keep on re-rendering this particular component, therefore you optimize it using the useCallback hook. And the second one I showed you is when you have a useEffect and you don't want this useEffect to run on each re-render, therefore you optimize the function right here so that it doesn't change on each re-render. And there might be other cases whenever you just want to optimize a function in React, you can make use of the useCallback hook. Okay, so that is it for this video. If you enjoyed it, leave a thumbs up and I'll see you in the next one. The useMemo hook is the most important hook in React when it comes to optimizing values. And in this video, I'll teach you everything that you need to know about the useMemo hook so that you can start using it in your React application to optimize values. useMemo hook is so similar with the useCallback hook. They are both used to improve performance in React applications. The only difference being that the useCallback hook usually returns an optimized function, while the useMemo hook usually returns a memoized value or an optimized value. So let's see the application that we have here and we'll see the problems that we are having, and then we'll try to make them better by making use of the useMemo hook. So right here, we are printing the last number of an array of numbers, Okay, and then right here we have a count button. This just increments the count. And then here we have another button which changes the size of an array. And when we change the size of an array, we will reprint the number here for the last value. So whenever I click on count, you will notice that it takes some time before it updates. And whenever I click, it takes a few seconds before it updates to 2. So there is something wrong happening here. And right here, whenever we change the size, it also takes some time before it updates this value and also this value here. So you'll notice that the entire of our application is slow. So let's take a look at the code and we'll see the reasons why this application is so slow. So right here, we have this handle count, which is being called by this particular button whenever we click it, and all it's doing is incrementing the count. So very simple right there. And then here we have this other function which is being called by this change array size function, and all it's doing, it is setting a random array size. Okay, everything looks good there as well. Now here we have this function, and this function, what it is doing, it is creating an array depending on the array size that we have right here. And apart from that, it is also getting the last number in that particular array. And finally, it is returning that number. And we print that on the screen right here. Okay, so we get it here. So right here is where our issue is. This is a very heavy computation that is happening right here, because it will create an array from 1 up to this array size, and to begin with, the array size is 100 million. It will create an array with a size of 100 million, going through each number and adding it to our big array right here. So this loop is a very heavy computation that is happening. And then also, when getting the last number, we are also performing a very heavy computation right here, because we are going through each number. And at the end of it all, when we get to the very last number, we will update our variable here and return it right here. So this is also a very heavy computation, because it is going through 100 million items and then returning the very last one right here. And that is why our app is very slow, because whenever we change the count, our app will re-render, and meaning that this heavy computation will happen each time, and therefore it will take some time before it updates our UI. It has to go through all those items before it updates our UI. The same thing happens right here with this other button. Whenever we change the array size, it will go through all these items, create a new array, and get the last number before it updates the UI. So you see the issue that we are having. So how can we make this better with the useMemo hook? So the useMemo hook work in a similar way as the useCallback hook. So the first thing that we will do, we will just import useMemo like that. And then we need to wrap our function right here with the useMemo hook. So right here, we'll say useMemo, and then we will invoke right here and make sure to close the bracket at the end here. So useMemo hook accepts two parameters. The first one is a function, and we are now already passing a function right there. And then the second one is an array of dependencies, just like the useCallback hook. And once we do this, what useMemo will do is that it will return a value, a memoized value, and it will only recalculate this particular value if our dependencies changes. Okay, so right now we are not adding any dependencies, and let's see what we have if we don't add any dependencies. Okay, let's save this one. But we have one issue, because useMemo returns a value. Now this will no longer be a function. We should not like call it like this. So we should remove this call to this last number, because this last number is now just a value. So I'll go ahead and save, and let's refresh here. Whenever we click on count, you'll notice that count updates very fast. Very nice. So basically, our count functionality have been optimized by making use of the useMemo, because this the last number is not being called on every re-render, which is good. And then we have this change array size. Change array size is fast, but you'll notice that it is not affecting our last number right here. But whenever we change the array size, we should also print out the last number of that array. The issue is we didn't pass a dependency to our useMemo hook right here, because this useMemo depends on this array size. So here we should pass our array size for this to work well. Array size there, and then I save. What will happen now is whenever we change the array size, useMemo will recalculate our last number. But if we don't change the array size, useMemo will not recalculate this function, but just return the previous value, which is same as the current value. So let's now see if this works. I refresh again. Count updates very fast. Very nice. Now when we change the array, this takes some time, but not too much time, and it updates right here. We click on change here. It takes some time, and it updates here. So our count is optimized, but change array size also takes some time, because that makes sense. This recalculation will happen again whenever we change the size. So this being slow makes sense because it is changing the array size, and useMemo depends on array size. So whenever array size changes, this calculation happens again. But the good thing is the rest part of our application, if we had any other feature in this application, they would also be optimized, like this button right here. So that is the work of the useMemo hook, to return an optimized value or a memoized value. And in most cases, you might not need to do so. So I recommend to make use of the useMemo hook whenever you see your app is getting sluggish and you have some heavy computation happening. And then in that case, you can try to make use of the useMemo hook to optimize your React application. So that is all about the useMemo hook. If you enjoyed the video, please leave a thumbs up. So I'll see you in the next one. The useRef hook is the most important hook in React when we want to get reference to a DOM element, or even manipulate the DOM directory without causing a re-render. We can also make use of the useRef hook to store a value that persists across renders. And in this video, I'll teach you everything that you need to know about the useRef hook so that you can start using it in your React projects. So here we'll go through several examples. And the first use case is adding a focus to this input field whenever we click on this button. And then we'll go through other examples as we move on to help you understand even further. So the first thing that we need to do is to bring in useRef hook. So here I'll bring in useRef hook from React, just like that. And then I'll create a variable here, and I can say const input ref. And I'll set this one to be equal to our useRef, and we invoke it. So now we want this input ref to be aware of our input element right here. And for that case, every element have an attribute called ref, and we'll set that to be equal to our input ref. And with this, we are able to access this input using our input ref. And to confirm this, we can log this input ref to the console, but I want to do that after our component mounts or renders. So I'll make use of the useEffect hook. So here I'll add an effect hook just like that, and we will console.log of input ref. But to access our input right here, or our element, we need to add .current. And this .current is where React stores our element or even our values. So we have to add that. So now I'll go ahead and save. And when I save, you'll see on this other side at the console, we have our input field, and it is exactly this particular input field. So we are able to access this input field using this input ref, and that is because of our useRef hook. So to add focus to this input is very easy. We just need to go to the button right here, and then we will add an onClick event, and here I'll call an arrow function, and we will say inputRef.current, and now we know that that is our input here. And what we will do, we will just call the focus method. So I call focus, make sure to invoke it, and I save. And now whenever I click on this focus input, you'll notice that it focuses our input field. I click and it focuses our input field. You can also make it such that whenever our app loads, it focuses the input field by default. So this is something that you might see in chat applications. So whenever you visit the chat, the input is automatically focused. So we can make use of ref to do that. And all we need to do is to call this input ref.current.focus whenever our app loads. And we know we can do that in our useEffect. So in this particular useEffect, I can add right here a dependency array to make sure that these only run once whenever our app renders. And then we will add this code right there. And I can remove this console log, and I'll go ahead and save. And now whenever we refresh here, you'll notice that our input is automatically focused, which is really cool. Now the other thing that we can do with the ref, we can use it to clear our input. So right now I can type, but we can make use of this button to clear the input. Right now whenever I click, it doesn't clear the input. So that is also very easy, because I just need to come to this button, add an onClick event. So I'll say onClick and open these brackets and an arrow function here. So here I can just open the curly brackets, and I can say input ref dot current dot value, and I'll set this one to be equal to an empty string like that. Now I'll go ahead and save. Right now we have this text in here. Whenever I click on clear input, it clears the input. And all these does not cause our component to re-render. So the last example here, when working with the DOM elements, is when we want to automatically scroll to the bottom of a particular container. And this again is useful in chat applications. Whenever you send a message, you want the chat to be at the very bottom as new messages come in. You don't want the chat to hang at the top. So we will create this auto scroll behavior whenever our component loads using the useRef hook. So the first thing that we need to do is to create a reference to this particular div, which has our overflowing content. So here we can create a new ref variable, and I'll say const, I can say content ref to be equal to useRef, and then I come to the very bottom, and right here we'll say ref is equals to, we set it to our content ref, and with this our content ref will hold this particular div as we saw earlier. So if we go ahead and log it to the console, I save, you'll notice that it is holding our content. Therefore we have access to that div. Okay, so now whenever our app loads right here, we can first make sure that we have that ref. So we'll say if we have our content ref.current, we will go ahead and we want to trigger a scroll. So here we will say content ref.current.scroll top, and I'll set this one to be equal to our content ref.current, and then we say scroll height. Okay, and with this, whenever our component renders the first time, it will automatically scroll these to the bottom. So I'll go ahead and save this. I will refresh here, and look, it's at the bottom right here. And to verify that, whenever I remove this and save, and we happen to refresh here, you'll notice this is at the top until you scroll. So if you have a chat application and messages are coming in, you don't want this to be at the top, you want it to be always at the bottom. So you can add a functionality like this one. So whenever it's at the top and we refresh, it will come at the bottom. So that is one of the use case of the useRef hook. You can access the DOM elements directly and even manipulate them without causing our app to re-render, which is awesome. So the other use case is that you can make use of the useRef hook to store values. Okay, you can store any kind of a value. You can store a number, you can store a string, a boolean, an object, all those data types. And in this case, I want us to store a number to count how many times our component will render. So here I'll create another ref and I'll say const render count will be equal to useRef, and we store 0 here, and here we can print that to the UI. I can say render count, make sure it's in curly brackets, dot current, just like that. I save and you'll see it's right here. This is our count. Okay, I'll use another useEffect here. I'll say useEffect and we will call our render count dot current and we will say plus plus, so it will increment the value of our render count. So this, whenever our component re-renders, it will increment the count. So I save and let's type something here and look, it is counting, and the awesome thing is that it is not causing this component to re-render. Now if we were to make use of the state to store this count and also make use of the useEffect, that will be really awful because it will cause an infinite loop which does not stop, and I can show you how that looks like. So I can duplicate this useState here and we change these variables here to count and this one to set count. Okay, now if we were to update the state, we will do like this here. We will say set count, we get the previous count and we take the previous count, so I'll say +1 and I happen to save, and look, useState is causing an infinite loop, and what is happening is that whenever it updates the first time, this component will re-render and then it will call this useEffect. This useEffect will update the count, and whenever we update the state, that causes the component to re-render again. So this will go on and on and on, and you can see right here now we are at 70,000 re-renders, which is crazy. So this is another use case which we might want to make use of the useRef hook. Whenever we want to store some value and change that value and we don't want that to cause the component to re-render, that's when we can make use of our ref. I return this to our render count dot current and I save, and that craziness stops. So we have seen two use cases of the useRef hook. Whenever you want to access the DOM elements directly or even manipulate them directly without causing the component to re-render. And another use case is whenever we want to store a value like this render count right here, and that value persists across renders and it does not cause the component to re-render. So that is all about the useRef hook. If this video is helpful, leave a thumbs up and I'll see you in the next one. The useReducer hook is used to manage your application state in React. So in React, you can either use the useState hook or the useReducer hook to manage your application state. useReducer hook is mostly used to manage more complex and related state than the useState hook. So most of the time, useState hook might be enough, but when your application is big and has some form of related state which is complex, then useReducer hook might make things easier in that case. And in this video, we will work on a simple to-do app to see how we can make use of the useReducer hook to manage state in React application. So all I have here is an input field and a button to add a task. They are currently not functional, but we are successfully updating the value for our input field by making use of the useState hook. So I have this piece of state right here, task, set task, and we are making use of the useState hook. And when I come here, you'll see at our input, we have an onChange event, and we are simply updating the task using the value that we enter right here. Okay, so how can we make use of the useReducer hook to add a task? To make use of the useReducer hook, you just need to import it normally. Right here, we'll just say useReducer, and we invoke it at the top level like the useState hook. So we'll say useReducer, we invoke it. It usually accepts two main arguments here, and it also has a third argument which is optional. So in this case, I'll just show you with the two main arguments that we are required to pass. The first one is a reducer function, and this reducer function is simply used to update the state. So we haven't created it yet, but we will. So we pass a reducer there, and then the second argument is usually a default state, and in this case, we will pass an array. Okay, so this will return an array with two stuff. So we can destructure those two stuff here just like this. The first one is the state. So here we can say tasks, which will now be our state. And then we also have a function, and we'll call this function dispatch. And we usually make use of this dispatch to send actions to this particular reducer function. And then this reducer function will update the state and cause our component to re-render. Okay, so basically this dispatch will be used to dispatch actions or send actions to this particular reducer function, and then this reducer function will know what to do with those actions. Okay, so let's create this particular function called reducer. Right here, we'll say const reducer will be equal to, we invoke it. It will have two parameters here, state and action. And then right here, we set it to be an arrow function, and we do stuff in here. So the thing is, this dispatch will dispatch an action. Simply, it will send an action to this reducer, and we will receive that action right here. And we will use that action to correctly update our state. And initially, this state right here will be this default state that we pass right here. So by default, it will be an empty array. But you can have it as any other data type, an object, a string. You can have it as an array or any other. In this case, array makes sense because we want to have an array of tasks. So in this reducer, we usually make use of a switch statement, and we usually check the type of our action right here. And according to the type, we correctly update the state. But you can also have a default action right here, which will be to return the default state. Okay, and I'll explain to you the flow as we move on. But if you have used Redux before, these are common terms: dispatch, reducer, action, because useReducer uses the Redux pattern to handle the state. How can we add the task now? All we need to do is to come in here. First of all, we are checking if the task is empty or not. So if it's not empty, we go ahead and we submit our task. And what we will do right here, we will call this dispatch. So we'll say dispatch, we invoke it, and right here we will pass an object. And this object is now what we are calling an action. So this object must have a type. So in this case, we'll say the type is add, and optionally, it will have what we call a payload. So payload is any other data that we might need to update the state. And in this case, we need this task so that we can add it to our list of tasks. We pass a property called payload, and we'll say the payload here is our task, like that. So whenever we do this dispatch will send this action to our reducer function. So our action has a type and a payload. Sometimes you might have only the type, and in some cases you'll also have the payload, like in this case. Okay, so once we get the action, we switch the action.type, and then right here we can now use a case to check what type we have. So here we'll say case if action.type is add, then we will correctly update our state right here, and we can just return, and what we will return is the previous state. So we spread the previous state, and here I want us to add a task. Remember, our task right here is just a string, but I also want it to have an ID, so I'll pass an object with ID, and I can set the ID to be date.now so that it's unique. It's an easy way to set up an ID there, and I'll add a title, and the title in this case will be action.payload. So remember, our payload is the one that is having our task here, and our task is whatever we type here, and that's what I'm calling the title right here. Okay, so this is how we can simply update the state using the useReducer hook. I know it's a bit complex than the useState hook, but when it comes to more complex state and complex application, these can really come in handy. Okay, because the state here is related, all the actions that we'll be performing here are related, and it's an easier way to update the state if we have complex state. Okay, let me also come at the very bottom here. Now that we added our tasks, now that we added these, I can uncomment these, and what this does, it is mapping through our tasks. We get a task at a time, and we show the title and a delete button. So when I save here, we don't see it, but whenever we add a task successfully, it will show. So let's say here, run useReducer. I click on add, and look, we are able to list that task right here, meaning that it was added to our list of tasks. Then I can say run useState, and I click on add, and it's down here. So you can see our tasks here is being updated by our useReducer, and once it updates, it is performing a re-render, and that is why we are seeing the new task being added here on the screen. So let's have just a recap of the useReducer hook. The first thing is to import it. Once you import it, you will pass two things to this useReducer hook. We pass a reducer function, and this reducer function is used to update the state. Then we pass the default state. So this reducer function, the default state to begin with will be this empty array. Then this useReducer will return exactly two things in our array right here. It will return the state, and it will return a function that we can use to send action. And actions looks like this. An action has a type, and optionally it has a payload. And once we call this dispatch, it will send this object to the reducer function right here behind the scenes. So we don't directly see it here. And once this reducer receives this action, we can check its type. So we make use of a switch statement. You can also make use of an if statement, but switch statement is a more common pattern. So action.type, then we check, is that action.type an add? If it's an add, then we update the state like this. We add a to-do to our state. Okay. If it's a delete, then we will remove a to-do from the state. If it's marking a to-do as complete, then we will update a to-do. If it's clearing the state, we will have all that kind of related actions to that particular state right here, which is easier to manage if it's a more complex state. Okay, and that is why I chose to do a to-do app right here instead of a simple counter, so that it makes more sense. Okay, so now let's see how we can delete a to-do. So to delete a to-do, we will be clicking on this button. So when we click on that button, we will call this handle delete task, which is a function receiving our task ID. And this is the function right here. It's receiving that task ID. And all we need to do right here is to dispatch an action. So I can actually copy this, and I'll paste it here. So we dispatch an action. I told you action is this particular object, and here we will say that in this case we want to delete a to-do or a task, and right here we will pass that task ID. So I pass the task ID. Then we come back to our reducer function and we add a case. This was the first case. Then here we can add a second case. And in this case, we'll say that this is a delete action. So we check, is this a delete action? Then down here, we correctly update our state. All I'll do is that I will return our state.filter. So remember, state is an array. I will filter out a to-do. So here we'll have a task at a time. Then I'll check the task.id. So if the task.id is not equal to our action.payload, remember action.payload is the one having our ID. Okay, payload is having our task ID. So we check if this is not equal to this, then we will return that particular task in the new array. Remember, this filter will return a new array, and that array will have a new data depending on the condition that we pass right here. So basically this will remove the to-do that we delete, and the new array that will be there will only have the rest of the tasks or to-dos. And let's see if it can delete. So let's delete this learn useState, and look, it is gone. I delete this one and it is gone. So it is working well. Can add anything and I can delete it. This is how we can make use of the useReducer hook to handle the state. Okay, basically we will be dispatching actions, then we will be making use of this reducer function right here to check which action that we have. If it's add, then we handle the state. If it's delete, we handle the state. If it's update, we handle the state, and so on. Okay, now one last thing that I want to tell you is that when making use of the useReducer hook and working with complex state, these cases can become like confusing. You can make a mess, you can confuse the spelling, and if you make a mess on the spelling, it will not work. For example, if I remove this AD and save, you'll notice when I type here and add, what it will do is that it will check for each case, do we have add? Is our action.type delete? If it does not find this AD here, it will just return the default state. Okay, so we usually create some constants so that you don't mess up with the type. Okay, so let me show you how you can do that. Right here, you can just have const action types. We set it to be equal to add underscore task full colon. This will be add. Then we will have here delete underscore task. Then this one will be delete. So what we have done, we have created an object for the different types that we are having, and then we can easily reuse each of these properties across our application. So for example, for add, instead of just this, I'll use Control D to highlight even the one at the bottom, and now I can say here action types, and I'll say dot add task. Okay, like that, and we will do the same for this delete. So I highlight this, I remove that, and I can say action types like that, then dot delete task, and I go ahead and save. So what is the important of this? This means that even if we make a change here like that and go ahead and save, our application will still work because we are reading the same value for this case and this case or any other case that we will be having. So here if I go ahead and add, it is adding, although I changed the value right here. Even if it's that and I happen to save and we add, it's adding. So this is really cool for big applications to avoid making a mess on your types. So that is the useReducer hook. You can use it to manage more complex state and state that is kind of related, and you can make use of the useState hook to work with just the normal state or the simpler state on your applications. So how you handle the state is usually your choice, okay? So you can either use useReducer or the useState hook to manage your application state. So that is it about the useReducer hook. Leave a thumbs up and I'll see you on the next one. The useContext hook is the most important hook in React when it comes to managing global state. And in this video, I'll teach you everything that you need to know about the useContext hook so that you can start using it in your React projects to manage global state. So let's first see the problem that we have, and then we will solve this problem by making use of the useContext hook. So right here, I have this application and we have our app component right here, and we have several components. So we are passing this homepage component, and in homepage component, we are passing our profile component, and in profile component, we are passing the settings component. And finally, in settings component, we have this information which we see right here. So at our app, we have this particular piece of state, and I want to render this email at our settings. So how can I do that? One of the straightforward way is through passing the props. So we can pass email through props up to our settings. Let's do that here. I can just say here email, and I'll set this to be equal to our email like that. And I'll just copy this one right here because I'll need it. Save that file, come to homepage. We pass this again right here, but also make sure to destructure the email from props. So here I destructure email and I save there. Then in profile, I can start by destructuring the email like that, and we pass it via props to our settings. And in settings, we can destructure that email again here, email, and we can now finally be able to render the user email right here. And I go ahead and save. And once I save, you'll see that it is right here now. So this process of passing the data via props like this, we pass it from app to homepage component, from homepage component to profile component, from profile component to settings component, and then finally we get where we need it. It's called props drilling, and props drilling can get very hectic, especially in large applications. So imagine we had like 15 components and we have to pass the email through each of the components. So that will be a lot of work. So in big applications, props drilling is not a very nice thing, okay? It can get messy very quick. So this is where the useContext hook comes in. It is used to access some form of global state, and we can be able to use that state easily in any of the components directly without going through this props drilling thing, okay? So what do we need to do? The first thing that I'll do is that I'll come right here and I'll create a new file, and I'll call this one appcontext.jsx. And right here, I'll create an app context that will help us to manage the state. I can just say const app context will be equal to create context. So this is a function that comes from React, and we invoke that. Here by default it will be undefined, but you can usually pass any default state that you want right here, okay? But for now, I'll just set it to be undefined like that. And I want to also go ahead and export this app context like that. So the useContext hook is not usually used alone. It is used together with this create context or the context API in React to handle the global state, okay? This app context has what we call appContext.provider component, and that is what we usually wrap our different components that will consume our app context state with. So what I mean is that right here, we can wrap this homepage with app context. Right here, I import it .provider component like that. And I pass this homepage right here like that. And this app context.provider usually accepts a value prop, and in this value prop you can pass the data that will be accessible from the child components. So these child components include this homepage component and any other component that is a child of this homepage. So we will be able to access this value from any of these other components: homepage, profile, settings, and so on. I'll go ahead and remove this props drilling thing, what we had done before. So I will remove that and make sure to save this file. I'll go to homepage and I will remove all this props drilling that we had done here because we will no longer need them. And you can see now this component is much cleaner. Then we need to also remove from here. So let's remove this props drilling here and I'll save. And let's go to settings, and now we will not access our value like this. Okay, now here we will actually make use of the use context hook. So I'll just say const email is equal to use context. Now this is our hook. Then we invoke it and we pass app context. We pass this particular app context right here. So I say app context. And once I do this, this use context will get us the email that we pass right here as the value. Okay, and with that we'll be able to render it right here, and you can see we are successfully being able to render the email. So if I come to the app right here and we happen to change this email to, let's say, test, and I happen to save, look, we are easily able to access it like that. So what have we done? The first thing, we have created a context using this create context from React, and this is now like the context API. We get this app context and we are also exporting it. So once we export, that app context has a component called app context.provider, and we pass the values that will be accessible from any other component in our tree that we wrap right here. So we can access it easily even in our profile. So right here in the profile, I can also come here and say const email will be equal to, we call our use context hook like that, we invoke it, and we can be able to pass our app context. And just like that, we have our email right here without going through that props drilling stuff. And right here we can say we are at the profile, and we can render the email to verify that we are actually getting the email. So I save, and look at profile, we have our email. So this makes it easy to access this particular state. It is now global within our component tree. Another thing is that sometimes you might want to pass this data as an object because you have several states at our app right here. So let's say we were passing an email and a username. So what will we do if we wanted to pass that username here? So what we will do is that we can make this to be an object. So here I include the curly brackets. So we will be able now to pass the email and the username like that. But this will now throw an error. So at settings, we need to destructure now this from our app context. So we destructure that like that. And when I save, we are now able to access our email. If you want to access the username, you can just say username like that. You destructure it as well, and you can now be able to also maybe render the username right here. I'll just say username, and I'll go ahead and save. And look, we are able to read that username. So at our app right here, when passing the value, you can pass an object like this, and then you'll be able to pass a lot of state through that. Okay, so right here we might have a lot of state, making this app a component to be very heavy. And there is a simpler way of handling this, okay, by removing this app context provider right here and this state to our app context file. So how can we do that? Right here, what we do, we create a component and we make sure to also export it. So I'll call this one const app context provider. So this is like a normal React component, and I'll set it to be an arrow function like this. And in here, we usually return something. And now what we will return in this app context provider is this particular provider, app context.provider, together with the values. Okay, so what I'll do, I can actually copy the whole of this. So I'll copy, then I'll come here and I'll paste it here. But the problem is that we don't have this homepage right here, so I will remove that. And instead, this app context provider will receive the children components. So this is the children prop, meaning that these are the child components, which we will wrap with our app context.provider. So right here, I pass the children, and now I save. And now this children, you can consider it as this homepage and all the other components that will be wrapped with our app context provider. So I can copy this. Instead now of saying app context.provider and then we pass the value, we will just wrap this homepage with this app context provider component which we have just created. So let me wrap it nicely like that and remove this one like that, and I save. But we have an error because in our app context provider we have this email and username, but they are not accessible from this file. So what we can do, we can just cut this state from there and we come right here and we paste it here, and then we make sure to import the useState hook in this particular file, and now I save. So I come here. Okay, let me remove the imports, and you can see now this app component is much simpler, just like that. It doesn't have a lot of pollution of state and so on, and we can now manage our whole state in our app context.jsx file. So at app, we wrapped with this one, but we didn't import it. So let's import it, control space, and I import it, and I happen to save. And now look, we are able to still read our test at gmail.com, which is awesome. All we did is that we moved our logic now to our app context.jsx file, where we can manage the entire state right here, and we can pass that state through our values like this. And then at our settings, we read the state normally by calling our app context like this, which is awesome. There is usually one more issue that usually arises whenever we don't wrap our components with this particular app provider and we try to consume that app context at those components, then we get an error. What I mean is that if we remove this homepage from this wrap, so we are no longer wrapping our homepage with our app context provider, and I happen to save, look, we get an error and cannot destructure property of email of useContext as it is undefined. So we get that error. To get a proper error, people usually create a custom hook at our app context, and the custom hook looks like this. We'll say const use app context, and we set this one to be equal to an arrow function. And what we will do in this particular custom hook is that we will read the data normally like this. So I'll copy that and I'll paste it here. But now I don't want to destructure this. I just want to generalize that object as the app state. Okay, and we make sure to import this useContext hook from React. So we are bringing in useContext right here. We consume our app context by making use of this useContext, and right here we expect to get this object right here, which is our value. Okay, but if we don't wrap our component here with this provider, when we try to access in any of the child components, we will get that object as undefined. Okay, so what we usually do here is to perform a check. Does this app state exist? So we'll say, does this app state exist? So if it does not exist, we throw an error. So I can say throw new error, and here we can pass a better error message. We can say use app context like that must be used within the app context provider, And now this is a better error message that is telling us we are trying to make use of the use app context hook, which is our custom hook, in a component that is not wrapped with our app context provider. Okay, so how do we access the state with this use app context? We do that by just coming in the component where we need to access the data, like right here, and we'll just say use app context. So we should export it. Export this, save, come here, then make use of use app context like that, and we invoke it. Let's remove this one, and you can see we don't need to import the use context hook and the app context anymore from here, and we access it like this. But now when I save, we still have the error, but the error is different. And if I come down here to the last one, you'll see uncaught. Use app context must be used within app context provider. That means that we are trying to access our state, but these settings or any of its parent component is not wrapped with our app context provider. So right here, if we pass this correctly like that, we wrap our home page and we save. And right here, we happen to refresh. Okay, we still have an issue. Let's see what the issue is. We get that we cannot destructure the email from use app context because it is undefined. One thing that we didn't do is that we did not return this app state from our use app context. So after we get the state, we check if it is there or not. We should also make sure to return the app state. So right here, we return the app state like that. And I happen to save now, and there we go. Now we have our data being nicely rendered like that. We can easily make use of this use app context to access the state like this. Very easy. So here, if we wanted to access the username, we can just say const. We destructure the username from the state, username, and we set this to be equal to use app context like that, and we invoke it, and just like that, we have our username here. Okay, and we can be able to render it to verify that. So we pass the username, and I happen to save, and look, just like that, we are able to access that data without going through that props drilling steps. Okay, and this is the main usage of the use context hook, to access the global state from our app context. And that is it about this video. If you learned something, leave a thumbs up. So I'll see you in the next one. In React, the useId hook is used to generate a unique ID, which can be passed to element ID or accessibility attributes. And here we have a situation where we might need to make use of the useId hook. So consider we have this password input, and this is a component type password, and the ID here is password. So if we were to reuse this password input component right here, one for password and the other one for confirm password, you'll notice that even our browser is complaining that we have two elements with non-unique IDs. And this is one of the situations where you can make use of the useId hook to generate unique IDs for the inputs. If I come right here, we can just import the useId hook and make use of it right here. So if I say useId and click on this one to auto import it, so you can see it's coming from React, and we invoke this will generate a unique ID whenever this component is being rendered. And here I can say const ID is equals to useId, and now we can make use of this ID right here. So I remove that and I pass the ID and I save. And whenever I save and happen to refresh here, look, we no longer have that warning, and we can log this ID to the console to see how it looks like. Console.log of ID, and I save, and you'll see the IDs are unique. You see this one has an ID here of R1, and the second one is right here of R3. So another situation where you might find making use of this useId hook is, for example, when you have a checkbox like this one. So this has a HTML4 as LAN hooks, and the input has an ID of LAN hooks. So whenever we click this label, it should check this input right here because it has a type of checkbox, and these are the same. So let's see how that looks like. If I uncomment this one and save, you see we have two of them right here. And for the first one, whenever I click on LAN hooks, it should check that particular checkbox. But now whenever we duplicate it, that means that we will have two checkbox with the same ID. Okay, and if they are the same and I happen to click the second one here, the label for this one, you'll see that it's marking the first one as checked instead of marking the second one as checked. So you can use the useId to solve this issue. So I can say useId here, I invoke that, and we can store that in constant. Then instead of using this one, we pass ID. Okay, so here use ID for both of them, and I happen to save. Okay, once I save, and let's just refresh, I click on LAN hooks here, that is checked well. When I click on the second one, it is checking the second one. That means that the IDs now are unique. So yeah, that is the useId hook. You use it to generate unique IDs, which you can pass to HTML element attributes, either for accessibility reasons or for element IDs like these ones. And one thing is that you should not make use of the useId hook to generate keys in a list. Okay, keys should be generated from your data. So this is the case where you map through the list and you are required to pass a unique key. So don't use useId to generate the unique keys for a list. Okay, so that is it for this video, and I'll see you in the next one. The use hook is the most unique hook in React because it does not follow all the rules of hooks. For example, you can be able to use the use hook inside conditions or even inside loops. But like other hooks, you must use it inside a functional component and not a class component. And in this video, we will cover everything that you need to know about the use hook so that you can start using it in your React projects. So first things first is that this use hook came with React 18 and it is not ready for production. So it is only available in React Canary and experimental channels. So avoid using it in production because it might have breaking changes anytime. Okay, but it is very interesting because it simplifies a lot of stuff. For example, we use it to consume a promise or a context. So just like the useContext hook, you can use the use hook to consume a context. And now it is even better because you can make use of it inside conditions or even inside loops, which is not possible with the useContext hook. And let's see an example where we make use of the use hook with context. So here in React docs, they have just a very simple example here. They are consuming a theme context. We import the use hook from React just like that, and then we pass the theme context and we get the theme just like with the use context hook. But the good thing now with this use hook is that we can use it inside conditions or even inside loops, which is not possible with the use context hook. Now, another thing about this use hook is that you can use it to consume the promises and you get back your data. So I have an example right here, which we consume a promise with the use hook. So first things first, here we are fetching with the useEffect hook this data right here, and this is the list characters component right here. So when making use of the useEffect, we call the hook, we set the states for loading, for error, and then we make the call right here with the fetch API. We pass the URL, we get a response, convert the response from JSON, and we get our data here, and we set the data. If we have an error, we set the error, and we remove the loading state whenever all this process has finished. So this is how we could fetch data normally with the fetch API, and then we set the states for each of them like that. And down here we display the loading state, and also we display the error if we have any, and here we list the characters. So this is the normal flow when fetching data in React and making use of the useEffect to fetch the data whenever the page loads. And as you can see right here, we are making use of about 40 lines of code to accomplish this. But with the use hook, this is much easier. Like you can see in this other component, we are also fetching data with the use hook, but now right here we have just 15 lines of code instead of 40 that we had before. And the first thing that I'm doing right here is to import the use hook, and then right here we will set our characters to be equal to the use hook. Then we pass a promise, and this use hook will be able to wait for that promise to be fulfilled and return our data. So we are using it here the same way like you will use the await, async await. Okay, we just call use, then we pass a promise like that, and we get our data. And then all we do right here is to map through the data and show it on the UI. But you might ask yourself, how do we handle the loading state, or how do we handle the errors? So in React 18, we have something we call the suspense component. So we need to wrap this particular component with the suspense component whenever we make use of the use hook. So I'll come here, go to app, and you'll notice that here I am wrapping the list characters with use with this suspense component like this. Okay, and what this will do is that if the data is still being fetched, we have this fallback prop which will be rendered if it is still fetching. Okay, and it will show this loading state right here. So this is how we handle the loading state when making use of the use hook. Okay, and this helps us to avoid all that code, and we can have just an easy way of fetching the data like this. And now how do we handle the errors? So also with React 18, we have what we call the error boundary. So we have a component that we can create called the error boundary like this. And it's good to note that at the moment, the error boundary can only be created as a class component. So as you can notice here, this is a class component. But again, you don't need to worry about this, because I think there is a library which you can just install, and you don't have to create this component by yourself. Let me show you that. I think we can search here for error boundary, and I think we have it here, catch rendering errors with error boundary. You see this component right here. Just in React docs, you can get the syntax of creating this error boundary component, and then you just need to wrap your component with that error boundary and add a fallback. And I want to show you something. So there is currently no way to write an error boundary as a functional component. However, you don't have to write the error boundary class yourself. For example, you can use this instead. So this is a package which you can install, and then you don't have to write the error boundary component yourself. So you just install with npm like that. Then you can use that component to wrap whichever component you want to. But again, it's not like hard to create this particular component. Just from React docs, you can copy it the way it is, and that is what I actually did here. Just removed the comments, nothing much. And now how to use this to handle the errors when making use of the use hook. You just need to wrap right here with the error boundary component. So here we just say error boundary like that, and we pass the entire of this part in there. I save, but I should pass a fallback like this one. So I'll copy this one and I'll paste this one here, and here we can say an error when fetching data. So this is what will show if we have an error. Okay, I save. Now to test this, we can invoke an error by rejecting a promise. So this is a successful one. Let's duplicate this one and let me comment out this one. So then here I will reject a promise by just saying promise.reject, and I can say here error, just like that, and I save. Fetching data with the use hook here would fail, and then our error boundary would catch that error and we would see this particular UI. So let's see if that works. If I come back here, let's refresh here, and look, an error when fetching data, and that is exactly what we passed here. And whatever we are seeing at the console here, this error is what we included right here, this error message. So we can verify that by adding anything like this. I save and I refresh, and you see we get that error also. And you can handle this error inside this error boundary component. So this log is the one that is giving us this particular error. So anyway, this is how you can handle the error when you make use of the use hook to consume a promise. So we have this error boundary that will handle the error. Then we have this suspense that will handle our loading state. And then in our list characters, we just make use of the use hook, and now it's very easy to use with a few lines of code, unlike the other way of fetching the data with the useEffect, which took us like 40 lines of code. So it's just a simplified way of doing it, okay? And as I told you, we can make use of the use hook inside conditions, okay? So right here, we can say, for example, let's create a constant of fetch data to be false to begin with, and then we will perform a check. If fetch data is true, that is when we will perform this action right here, the one that was fetching our Rick and Morty characters. Then let's remove these and let's remove the comment. So this is an illustration that you can make use of the use hook inside a condition. So in this case, fetch will be false, and therefore it will not be able to fetch this data. Okay, I think these characters is not defined down here, so we can create it as a variable. I can just say let cars, like that. Here we update cars, okay? And here let's just use a question mark in case of anything, and let me save. So if we check now and let me refresh and I scroll down, look, we don't have any data because this fetch data is false. But if we changed this one to true and I save, and then I come back to our app, and look, it's now fetching the data like this because this fetch data is true. So we can make use of it inside a condition, unlike other hooks, okay? So that is the use hook. If you liked the content, leave a thumbs up, and also subscribe to the channel, and I'll see you in the next one. The useTransition hook is used in React to let you update the state without blocking the UI. And in this video, I'll teach you everything that you need to know about the useTransition hook so that you can use it in your React applications to optimize your UIs. So here I have a very simple example. All we have is this button, and this particular button generates a random array, and also we are keeping a count of how many times we click this particular button. So when we click it, this function is the one that will be called right here, and the first thing that it's doing is to update the count to increment by 1, and the other thing that it will do is that it will generate this particular array, and it's a very big array of 10,000 items, meaning that it can be slow, especially in lower level devices. And that is why also in my console at performance, I have also made my CPU to be 4 times slower so that we can easily illustrate what is happening here. And then finally, after we generate this big array, we show it on the screen by updating the state here, and then we'll show it on the screen. So let's see what is happening. I click this button and look, it is frozen, kind of frozen. But what is happening is that it is taking time to update this count, and also it is taking time to generate that big array right here, and it is so slow considering I have also make this to be even slower, and that is why our count is lagging behind, and also our state update right here is also lagging behind. It is taking time to update. So whenever I click, the count does not update immediately, but it updates together with this particular state right here. So how React is doing is that it is waiting. So whenever we update this state, React will wait for all the other states to also be updated, and then after all the state is ready, that is when our UI will show. So basically we should be seeing this count being updated immediately because the state was updated first, but we have this code that is blocking the UI, and until this other state right here is ready, that is when both of the UIs are updated. So when I click, look, both are behind. So we can make use of the useTransition hook to prevent this particular state from blocking this one right here for the counter. For the counter, it should be fast because we don't have any heavy computation for the counter. The heavy computation is for this particular random array. So all we need to do is to import the useTransition hook from React. So here I'll say use transition, and then we should invoke it at the top level, just like the useState hook. So here I can say const. Here we will destructure something from this useTransition hook. So I say useTransition here and I invoke it. We destructure exactly two things. One is pending, and the other one is start transition function. And then this start transition is the one that will help us to prevent this code right here from blocking this state update. We will come right here and we'll say start transition, and we just call this, we pass an arrow function in here, and we pass the curly brackets. And what we will do, we will take this code, I'll cut that, and I'll pass it to be inside the start transition function. And this start transition function is coming from our useTransition hook. So whenever now I save and let's test it out, I click this and look, our count immediately updated, even though this other state right here, this random array state, is not ready. So this count is now updating immediately, meaning that this state is not blocking this state. Okay, so I click, look, our count updates first, then this follows. And this is the work of the useTransition hook to prevent some state update from blocking the UI for other states. Okay, and the good thing is that it also have this particular is pending state, and what that will help us is to check if we are still updating this state right here. And if we are doing that, we can show a loading state right here. So I'll say if it's pending, then we'll show this div that the state is still loading. So let me refresh and you'll see that in action. I click, loading, this has updated, and that means that we have something that is pending right here. And once it's ready, loading will not show, but it will show our updated state. I click on this. You see, we have that loading right there. Now, one thing that you should know is that you should not pass a synchronous function inside the start transition function. Otherwise, it will not work as expected. Okay. Another thing is that you should not pass a set timeout in here. Okay. And we can verify that from the official React documentation. So one thing that you see is that you should not call set timeout inside a start transition. Instead, you should do the other way around. You pass start transition inside the set timeout. Also, you should not pass a synchronous function inside the start transition. Instead, you pass start transition inside a synchronous function. Okay, so you should note that. Another thing, you should not make use of start transition when you want to update the state of a controlled input. Okay, so that will not work well. And if you need another example, we also have another example in the official React documentation here of this particular hook. So let me show you. So here we have this particular application, and what it does is that we make use of start transition for updating the state for the different tabs. And you can see the code right here. This is start transition, and we have set tab right here. And what it is trying to do is to optimize switching between the tabs, because this posts right here is a slow component. It has some logic that makes it slow, and then this is fast, this is fast. But if we don't make use of this start transition, this post will block the update of the other if we try to switch very fast between them. So if I come at the top, this is when we are making use of the transition. This is when we are not making use of the transition. And if we are not making use of the transition, I click on post. Look, it takes time to show. Contact doesn't take time to show. But when I click on post, then contact very fast, you'll notice that contact took some few seconds to update because it was waiting for post to complete a state update so that it actually shows. Okay, let's do that again. Post contact. Look, it took some few seconds to show. Then if we use transition, you'll see that now it's optimized right here. Let's click post contact. Contact is showing immediately. This post does not block contact UI. So you can take a look at this other example here to learn more about the use transition hook. So that is all about this particular hook, and I hope you enjoyed the content. If you did, leave a thumbs up, and yeah, that is it.